Hello, my name is Christopher Losinski, and this is a tutorial about teaching Python and Jinja in the browser. There'll be about 15 minutes of lecture at the beginning of the class, and then I'll take questions, and then those people who may not want to stay for all of the Python exercises can leave at that point. Are very welcome to stay also. Okay, so you can learn more at forestwiki.com. You can play with the demo at demo.forestwiki.com, and you can see the slides at forestwiki.com/slides.pdf. So there's a huge difference between online learning and teaching. Online learning is a very solitary activity. Maybe you watch a video, you go to a website. Teaching is a very interpersonal activity. The teacher has very direct relationships with a whole classroom of students. I actually knew a teacher, and she had tremendous knowledge about each of their students, not only where they were academically, where they were emotionally, what their home life was like. And so the Forest Wiki understands and respects the relationship between the teachers and the students. It's also important to realize that teaching is hugely different from programming. If you're interested in teaching, it's very interesting to study the work of Jean Piaget. He's a very famous psychologist known for his work on child development. He's particularly interested in epistemology. And he had sort of two sets of theories. One of them was that learning progresses in different stages. You start off with just physical motor skills. Later on, you develop visual skills, and eventually you develop conceptual skills. So all three are active at any point in time, but they're obviously different strengths at different ages. And the other concept he had is that you build on concepts. So just take mathematics. In math, each concept builds on the previous concepts. So we start off learning to count. From there, it's addition, subtraction, multiplication, trigonometry, geometry, and then eventually all the way up to calculus. Every concept builds on the previous concepts. The next big work was done by Papert et al. On the Logo programming language. So what they did is they took Piaget's concepts about visual learning and applied that to help students develop the conceptual learning. So a lot of work on that. I'm just barely touching on it. The next company we should speak about is Runestone Interactive. They're the only other company that does online teaching. A lot of people do solo online learning, but they support software which does online teaching. It was very impressive. He teaches college students, and he uses the software himself, so he's really polished up the interfaces. But there's several issues. First of all, the last point, they do turtle graphics only in chapter 4.2. So clearly he's not focused on beginning students. He's focused on college students. So they start off with the abstract concepts. And they run a large Web2Py server, and they have a lot of hosting costs. So they have to charge for the content. So the software is free, but if you want a class, then I think they charge like $100 a year for the content to teach a class. And of course, it only does Sculpt. I should add that they're now working on moving it to Docker containers, something small that everyone can just install on their local machines, but that hasn't happened yet. The Forest Wiki starts off as a Docker container. The next company that deserves honorable mention is Anvil. I'm very much looking forward to their talk tomorrow at this conference. They made major contributions to Sculpt, and in particular working on the debugger for Sculpt. Sculpt is Python implemented in JavaScript running in the browser. So they've made major contributions to that. Thank you very much, Anvil. So there are a lot of advantages, benefits to teaching Python in the browser. First of all, you only have one installation. You don't have to install it on everybody's computer. You just install it on the server somewhere. Then the teacher can monitor the students' work remotely. Particularly in the time of COVID, you should be at least 2 meters away from your students, and you can't even look over their shoulder at their screen from 2 meters away. Better to be working remotely and accessing their work over the internet in a web browser. And that's great that we don't have to learn a shell. There's no shell needed. Everything's done on the web. And the best part is it's not JavaScript. I don't want to be too hard on JavaScript. It's a good language. But if you're teaching, you really want to focus on the concepts, and Python has very clear concepts for software development. So it's a very good place to start. Later, if they have to, they can work with JavaScript. Of course, the other column are the deficits. The biggest problem is the lack of the debugger. We'll get into this in a moment. The libraries, most of the Python libraries are not available in the browser on JavaScript. And then there's the limitations on the syntax checking editors in the browser. So you got benefits and deficits. You have to make your choices. But you actually have multiple choices. It turns out, I think there are like 17 or 18 different Python interpreters in the browser. 3 of the majors are Sculpt, Pyodide, Transcript. Maybe I should mention Batavia also. If there are others that you're very aware of, please let me know. So let's focus on Sculpt. Is it Python? Well, it's pretty close to Python. Is there a syntax checking editor? Well, yes, ForceWiki includes a syntax checking editor for Sculpt. I think it's the only one that does. Is there a debugger? If you go to the Sculpt website, they speak of a debugger, but I haven't seen it running on everyone's website, and they say it needs work, so we'll see what Anvil has done for all of us in their announcements tomorrow. Python libraries, well, not many. And JavaScript libraries, well, I think you should be able to access all of them. So that's the Sculpt. Python implemented in JavaScript. The next one is really interesting. This is Pyodide. This is maybe the one that I'm most familiar with. Actually, last year I was teaching Pyodide classes until COVID hit. Now I'm trying to do it again online. Is it Python? Yes. Pyodide is cPython compiled to WebAssembly and running in the browser. So it really is the most recent release of cPython. Is there a syntax checking editor? Yes. I will be demonstrating one for you shortly, and it correctly catches all the Python 3.8.2 syntax errors because it uses Python to check for them. Is there a debugger? Well, that's the problem. WebAssembly doesn't have debuggers. That's a big problem. Python libraries, well, yeah, excellent Python libraries available with Pyodide. The whole data science community, a lot of their libraries have imported to Pyodide running in WASM in the browser. So brilliant libraries. And JavaScript libraries, well, I mean, there's some it's kind of fun interfacing Pyodide to JavaScript. So you can do that, but it's not really calling JavaScript libraries from Pyodide. And then the last one, and there's the dark horse in the room, maybe people don't talk about this much, but it has a great reputation, it's Transcript. So Transcript is actually, it's transpiled on the server. So I believe they use the Python parser to import the transcript, and then they export from that, they export JavaScript. So they do this sort of typically on the server. I probably do it in Pyodide, would be interesting. We could scale to the classroom much bigger. They do that on the server and they generate JavaScript. So it's very elegant. Is it Python? Well, it's halfway between Python and JavaScript. They had to make a large number of difficult choices. And my understanding is they made their choices very well. So it's not really Python, but it's really nice. Is there a syntax checking editor in the browser? No, I'm pretty sure there isn't. Does it have a debugger? Well, yes. Google Chrome does source code debugging. So Google Chrome understands transpilers, so you can actually debug at the Python level. It's got excellent debuggers, and the Chrome debuggers are very good. Python libraries, well, any pure Python library you can compile with transcript, but if it's like based on C, then that doesn't work. And JavaScript libraries, it also has excellent JavaScript access to JavaScript libraries. So today I'll be demonstrating the Sculpt and Pyodide. I actually have Transcript sort of running. It needs a lot of testing. So if anybody's interested in working with Transcript, in a couple hours I can get you, certainly in a day, I can get you a Transcript editor in the browser. So lots of different choices. And depending upon your use cases, you can choose which one best fits your needs. Okay, so let's get to teaching turtle graphics. From a software perspective, turtle graphics is really pretty simple. It's Python, presumably you all know Python. You draw some lines, you do some turns, you take some shapes, pen up and pen down, background. Teaching turtle graphics is not very impressive from a Python perspective, but it is very impressive from a teaching perspective. And I now understand better the Piaget's concepts, okay? So it's very difficult, particularly for younger people, to grab the concepts. And so by having the concepts visually moving around on the screen, they can really understand it. So conceptually, it's really very powerful. And also emotionally, it's very powerful. Maybe Piaget was very academic, focusing on the concepts, but just look at the emotional reaction people have to these graphics, spirals, and all kinds of beautiful things, triangles, more spirals, more spirals. You can also do paintings, various paintings. I kind of like this one. What is the most exciting image that every student has seen? Well, if you're a teacher, you'll know the answer to this one. It's this one. When they first draw that first square, they're like, wow, I can program. It's kind of a big bang, eureka moment. Very exciting for students. It's really fun to teach the students and see their reactions when they do this. And maybe I should show you all the ones they got wrong too, but no one ever shows that in lectures. Okay, so there are a bunch of simple turtle commands. It doesn't take long to master this, just a few minutes. Turtle can go right, he can go left, he can go forward and backwards. In the middle column, you can draw a circle. If it's got a solid center, then it's a dot. You can go to an X and Y location. X is horizontal. You can go home, middle of the screen. On the right-hand side, you can set the colors, fill colors, pen colors, background colors. There's actually a lot more commands, and one of the exercises will be encouraging you to go to the turtle documentation just to see how rich it is, what can be done. But it's good to be able to start something easy. Okay, so here we get to the end of, we're going to get to the end of the talk in a minute. Let me switch to, I'm going to show you a couple demos, and then those people who don't want to stay for the exercises can go. So here we have a bunch. If you go to forestwiki.com, you can click into the turtle graphics, and you can see the different graphics, different assignments. So remember, this is not just about a student doing an exercise. This is about a teacher supervising the process. So here is what the teacher sees. You want to make the spiral go counterclockwise. So the teacher has a WYSIWYG editor where they can create the assignment. And then they can give some code to the students. And then the students can run it. Okay. What the student will see is the student doesn't see the text editor, they just see the assignment, and then they see the program that they have to edit, and then they can go ahead and edit it. Let me back up. There's also an opportunity to do a solution. So here again, the teacher can edit the title, the students can't. The teacher can edit the solution to the problem. Here there wasn't much, and the teacher can edit the source code for the solution. But the interesting thing is the teacher can also look at the students. So this is organized as a tree. Here you have all the students' homeworks underneath the tree, and the teacher can click into any student. And it's taking a moment to load. Sorry about that. There we go. Okay, so here the teacher can see this particular student. It's running a lot on this computer. And in this case, you can see the student did a lot of extra work, so we can actually, you don't see all of this. That's just the turtle, right? But the student also, if we run this, you can see he has the turtle do a very nice message. The turtle is tired and taking a break, ... So the teacher can inspect the students' work. And then also I will show you, if you go to demo.forestwiki.com/cPython with a capital P/ACEdit, here is actually cPython running in the browser. So this is really cPython. It's really running in the browser. It's based on something called Pyodide, where they compile cPython to WebAssembly. And what's interesting is it has a syntax checking editor. So what I do here, I'm sure when all the other guys will start copying this, on every keystroke, I compile the code. And if it doesn't compile, that means there's a syntax error. And so you flag it and it generates, you can see here, cPython actually has very good error reporting on syntax errors. So it's really an excellent syntax checker. And it's going to get the IPython thing. You can, well, let's see, I can define something for you here. Let's see, define foo, print hello world. See, I always forget my colon, so, but if you add that in, then why is it not print hello world? Oh, extra space there. Okay, so you do that, and then you can run it or you can save it. And you can actually, you have to go over here to run it. Ooh. There you go, hello world. And so this is kind of the IPython type of Python REPL. Okay, so now we're going to break for questions. I'm sure people have a lot of questions about all of these technologies. And then after the questions, we're going to go into the exercises. I'll say one more thing here before we do. If you're interested, there's the contact information. forestwiki.com/contact.